we're going to talk about quadratic inequalities and more specifically how to graph them. So we've been talking about quadratic equations and we've graphed them, so you know that quadratics, when we have this x squared term, are parabolas. And so we want to look at some and what happens when we graph them. And you've been graphing them, graphing inequalities at least for years. You know that you have open and closed circles and pieces that get shaded and things like that, but you haven't graphed them yet when it's a parabola. So let's start by this. We're going to have f of x equals x squared plus x minus 6. Remember that f of x is just another way of saying y. We can substitute this any way we want. Now I'm going to change it and make it x squared plus x minus 6, and instead of f of x, I'm setting it equal to 0. And I'm doing this so that I can switch it up and factor it. Factor it so that I can find my x-intercepts. Now this is a very easy one. I can factor it to become x plus 3, x minus 2. I can set that equal to 0. And in doing so, I can find my roots in both my x-intercepts. I know my roots from this are going to be negative 3 and 2. Remember, you find your roots by setting x plus 3 equal to 0 and x minus 2 equal to 0. And when you do that, you end up taking the opposite of each of those equations. Okay, if my roots are negative 3 and 2, then my x-intercepts will be negative 3, 0, and 2, 0. You simply put a 0 at the y. Your x-intercept means it's sitting on the x-axis, so therefore your y-coordinate is going to be 0. Okay, so now I'm going to change this up. I want to say that f of x is greater than 0. So instead of being equal to 0, it's greater than 0. So I'm going to change my equation up here, and I'm going to say x squared plus x minus 6 is greater than 0. Okay, so the only thing that's different from here to here is that instead of an equal than sign, I'm looking at a greater than sign. Okay, and so I've still got the same x-intercepts because this is going to factor the same way. My y-intercept is negative 6. Keep in mind, to find that, I plug 0 into my x's. 0 squared is 0, plus 0 is 0, so then I've got minus 6. So I know that my y-intercept is negative 6, or if I wrote it as an ordered pair, it's going to be at 0, negative 6. Whoops. Negative 6. So I've graphed my parabola using my x-intercepts and my y-intercept. Had an x-intercept at negative 3, 0, 2, 0, and 0, negative 6. So now I want to talk about shading and how this is going to break down. I'm looking at where is this greater than 0. So if I look up here, where is it greater than 0? So I want to go back and set these here. Where is x plus 3 greater than 0? Where is x minus 2 greater than 0? And when I solve these, I find out, I move this over, I get x is greater than 0 at 2, and this one becomes x greater than negative 3. And so really, this is, you're going to find out that you can shade over here, and although this is greater than, we really need values that work out over here at less than negative 3. Even though this is greater than, we need values here. And your sign's a little misleading here, but it makes sense if you think about it, because this is positive here at signs less than negative 3. So the way we would write this would be that this is greater than 0 when x is greater than 2, or x is less than negative 3. And that's why we graph it when we're working these out, so that you can look at them. Now, if you want to test this theory, pick a number and plug it in. So what's a number less than negative 3? Negative 4 is less than negative 3. So if we plugged negative 4 into this equation, negative 4 squared plus negative 4 minus 6 is going to give you 16 minus 10, which gives you 6. Well, 6 on the x-axis is going to fall way over here, which is definitely greater than 0. Okay, so let's try it again with a number that doesn't meet this criteria. Let's say -1. That's not less than -3. So -1 squared minus, or plus -1 minus 6, that gives us 1 minus 1 minus 6. That lands us at 1 minus 7. Does that put us where we want to be? Actually, I think that one did work. A minute ago when I tried this, that didn't. Oh, whoops. This should be +1. Anyway. So, if you try them, they should come out. So, this is where you want to go. So, let's look at another example. Apparently, I did something wrong there. Alright, so here we have this quadratic. -x squared minus 3x plus 28. Now, you never want a negative here. So I'm going to start, and hopefully you've seen this before, by multiplying the whole thing by -1. And what that does is it gets rid of this negative, and it's going to change the sign of everything in our equation. And now keep in mind, when you're dealing with an inequality, if you multiply or divide by a negative, you have to flip this sign. So now, instead of -x squared minus 3x plus 28 is greater than 0, our new inequality is x squared plus 3x minus 28 is less than 0. All of that changed because I multiplied by a -1 to get rid of the negative in front of my x squared. Now, I'm going to factor this. Multiplies to give me 28, adds to give me 3. How about x plus 7 and x minus 4? So I know my x-intercepts are going to be at 4, 0 and -7, 0. My y-intercept, if I plug 0 in here, I get 0. 0 will be at 0 on the x and -28. Maybe we'll cheat that a little when we go to graph. So when we graph it, okay, our y is going to be way down here, and we know it has a minimum now. We've got an x over here at 4. We have one over here at -7. We're going to do this. Okay? Now, here's our question. What makes this true? So, x plus 7, we're going to have x is less than -7. And x minus 4, we're going to have x is less than 4. So we want to shade where it is less than 7 and less than 4. So we're going to shade down in this region. And really we could kind of get all of this because we want to be below, actually no, I don't know if I want to include all that, below all of that. So we will continue to practice on all this. We will also talk about whether or not you need dashed line or solid lines, and I think you know the reason when you get to class tomorrow.